Hi, this screencast is going to cover how to translate uh, requirements or something we call problem statements into our actual program code. So the question that we might be asking is, how do I know what to code? That is really the basic issue here. Okay, so when our programs are small, we can usually just write them. It's not much planning is involved in that. But most modern software could have hundreds, thousands. I've worked on code that had over 1 million lines of code. So it's probably a good idea to do some planning. So during this semester, our programs are going to get more and more complex. So we're going to think about ways how we can plan out what our code is going to do. Okay, let's talk about something called problem statements. Problem statements are also known as requirements. So they're typically just a few paragraphs that are meant to describe what your program will do. Right? They're typically written by non-programmers, and their goal is to communicate what they want the program to do as best as they can communicate it. So um, a lot of times some of these statements can be a little ambiguous, and it's really good to talk to your customer and get a good understanding of what it is that they really want. So let's look at a few examples. So here's one. Maybe you're asked to write a program that asks a user for 10 numbers. The program will then determine the smallest number, the largest number, and calculate the average of the number. The program will then display the three calculated values. Or how about this one? Write a program that asks a user to enter the height of a child for each year of their life. The program will then determine which year the child grew the fastest and which year the child grew the slowest and output the calculated values. This could be useful. How about this one? Write a program that asks a user to enter a temperature in Fahrenheit and convert it to Celsius. The program will display the Fahrenheit temperature and the calculated Celsius temperature. And they go ahead and give you the formula too. Celsius temperature is calculated by the formula 5/9 times Fahrenheit temperature minus 32. All right, so how do we break this down? Um, the best way to do this is one of the things that we want to remember, okay, and this is kind of the theme. You've heard me say this throughout the semester. A program does three things. It takes input, it does some processing based on that input, and then it produces some output. All right, so a program has things that it knows, which is the data, and it has things that it does, okay, which is the processing, all right? So we need to build up kind of a list of input variables and a list of output variables. And then we also have to develop a task list, a processing list, if you will. Okay, what are the steps or the processes that our program is going to do, right? And we can extract all of that information from any one of these problem statements, right? So the first step in doing that is that we want to extract the nouns and the verbs. All right, so um, let's take a look at this first problem statement right here. Write a program that asks a user for 10 numbers. All right, the programs will then determine the smallest number, the largest number, and calculate the average of the number. The program will display the three calculated values. Okay, so why are we looking at the nouns and why are we looking at the verbs? The nouns are what the program will know, okay? And the verbs are going to be what the program will do. Okay, so first the nouns. So, so these nouns have been highlighted here. So we take a look at this. Write a program that asks a user for 10 numbers. Okay, so there's one important noun. These are the important nouns. The program, well, that's a noun, but it's obvious that we're going to write a program here. It's going to determine the smallest number. Okay, smallest number, that seems pretty important. The largest number, and then it's going to calculate the average of the number. The program will display the three calculated values. So it looks like what we have here is we have 10 numbers, smallest number, largest number, and average. All right, so we'll go ahead and I've got their descriptive, the descriptive adjectives for those nouns also. So 10 numbers, smallest number, and largest number, and average are the important nouns. So these are the things that the program needs to know to get the job done. Okay, so the next thing that we're going to do is take a look at the verbs, and I've highlighted those here too. All right, so we write a program that asks a user for 10 numbers, right? And when we are asking a user for something, we're going to, you want to be thinking immediately with JavaScript, we're going to use the prompt function. So we're prompting the user, okay? So we're asking the user for 10 numbers. The program will then determine the smallest number, the largest number, and calculate the average of the number. The program will display the three calculated values. So the program's going to go ahead and determine from all of those 10 numbers which of these are smallest and which of them are the largest. And then it's going to go and calculate the average of the number. And finally, once it's done that processing, it's going to go and display all three calculated values. What are those calculated values? The smallest number, the largest number, and the average. So here are the verbs: ask, determine, calculate, display. All right, so now we've captured our nouns and we've captured our verbs. Okay, and then what we want to do is we want to put these into something called program planning lists. So you remember what I said is that all programs take input, they do some processing, and then they provide some output. All right. So it's kind of a pretty informal process. Once you take a look at these problem statements, and you won't have to always write down the nouns and write down the verbs per se, because we're going to go ahead and take a step after that. And what we'll do is we're going to take and convert these nouns into a suitable variable name. Okay, and then the processing steps are kind of what we want to do as far as processing goes. All right, so these are the three lists: the list of input variables, the list of output variables, and the processing steps. So let's just take a look at the input variables first. Okay, so we look at these nouns, and we want to sort of determine which of these nouns are going to be used as input. All right, so I look at the problem statement again, right up here. Write a program that asks a user for 10 numbers. All right, so looks like the 10 numbers are the input. Okay, and sure enough, I'll go ahead and translate them into 10 variables. So here's one way I could do it. I could say number and the digit 1 through 10. Okay, that's one way to do it. All right, but here's how I've done it for you now. Okay, so here are the 10 variables, number 1 through 10. Then I want to take a look at what the output variables are. So let's go look back at this problem statement here. All right, so I'm going to, and that's where I'm going to say what I'm going to display. I'm going to display the three calculated values. Well, what are those three calculated values? Well, it's what I determine here and what I calculate. So I'm determining the smallest number, the largest number, and I'm calculating the average number. So it's going to be the smallest number, the largest number, and the average. And those are going to be listed right here: smallest number, largest number, and average. So the steps that we want to do before, you might think, well, we take input, then we do some processing, and then we provide output. And you would think, well, maybe I should come up with the input variable list, then come up with the processing steps, and then do the output variables. Well, it's actually a lot easier to first determine what the program knows, um, being that here's the input variable list, here's the output variable list. And then it's a lot easier to sort of connect those dots between the input variable list and the output variable list on what the processing steps need to be. So that should be your last step, is creating a process checklist. All right, so it's where we're differentiating between, the variable lists are what our program knows, and the processes or process checklist contains what our program actually does. Right? Now this is considered to be sort of at a high level, so you don't need to put a lot of detail in it. You still want to stick with the what does this program do, not necessarily how. All right, it's very important as a program designer to put your um, to keep your what hat on and keep it sort of at a high level, because if you start getting into too much details too soon, things can get complex. If you don't know what the program is doing, then that can create some problems. So sort of a little computer science 101. It's really good to start at this high level, understand the what's, make sure you confirm that with your customer, and then start working on the hows. Okay, and for us, our how is going to be the algorithms in our programs. All right, so um, so we look at the verbs, all right, and we're looking for a pattern here. So the verbs are the candidates for, those verbs are candidates for being on our list of steps. So the first verb was ask, okay? This is getting uh, input from our user. And so we could rewrite that as prompt user for 10 numbers, right? Um, that seems simple enough, all right? And then, so we got that. So that gets our input. And then then we're going to do some processing, okay? So that'll be sort of our next step. So determine and calculate are our next verbs. And this is kind of the heart of the program. It's what it's actually doing. So the processing we're going to be doing is from those 10 numbers, we're going to determine the smallest number. So that's one step. We're going to determine the largest number. That's another step. And then we're going to calculate the average of all those numbers. Okay, and you might be thinking in your head, oh, I know how to calculate the average. I just add all those 10 numbers up and I divide by 10, right? And that's exactly what you'll be doing. And here's the interesting thing is that the more you start doing this conversion of problem statements into planning lists, program solutions are just going to start jumping out at you sort of at these um, subsection levels. So it's really a cool thing. Okay, so we have determine the smallest number, determine the largest number, and calculate the average. The last verb that we have is called display. This is the output step. So all we really want to say here is display smallest number, largest number, and average, because what did our what did our statement say right here? It said the program will display the calculated values. What are the calculated values? Smallest number, largest number, and average. Awesome. So there we go. So our process checklist, if we put it all together, is prompt the user for 10 numbers, determine the smallest number, determine the largest number, calculate the average, and display the smallest number, largest number, and average. So you want to go and review this with yourself and see if this seems correct. So, the long and short of this is that we've now I've given you an easy way to break down any requirement statement or problem statement into these three lists, which are called planning lists: your input variable list, your output variable list, and your process checklist. So what I like to do in my actual program code is I like to take and put a whole bunch of comments in there. Start out. So the first comment is going to be declare variables. So all of my input variables and my output variables are going to be defined right under my um, declare variables comment. And then I like to copy and paste this whole thing into my code as comments. And then I don't have to think about the what this program does anymore. All I have to do at this point is just write it. I can think about how it does it, which is my code. So I have these as comments, and then I just sort of boom, 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 knock all of these things out in order. And then before you know it, you have a program.